What's up, PCH? Today we're going to be talking about one of the topics on the SAT, graphing linear equations, which comes from the Heart of Algebra section of topics. And for a lot of us, this may seem like super easy, right? We know how to graph linear equations, and to an extent, I believe you, right? Like when we talk about the different forms of linear equations, slope-intercept form, point-slope form, and standard form. Um, I am pretty positive that we feel like rock stars when it comes to slope intercept form. Y equals mx plus b. We know it. We know how to work with it. And so I really don't want to spend my time talking about y equals mx plus b right now. Same thing for point slope form. While I think we're a little bit less familiar with it and working with it, it doesn't actually get tested quite as much on the SAT. It shows up a ton in calculus, so we're not going to ignore it. We will talk more about it later. But for our purposes right now, I really want to focus on the form of the equation of a line that is standard form, ax plus by equals c. Specifically because it is tested a ton on the SAT, specifically when they're asking about intercepts and when they're asking about slope and all of these things from the standard form of a linear equation. And so let's actually take a second to talk about intercepts. We have discussed these plenty already with different types of functions, but two things remain true no matter what. When we're talking about an x-intercept, the point that we have for our x-intercept is going to have some value, some number for x, but y is always going to be 0. When it comes to our y-intercepts, the opposite is true. We are going to always have 0 for an x value, and then some number y be our y value in the point for our y-intercepts. When it comes to trying to find intercepts from standard form, it's actually like really straightforward, especially compared to some of the other forms for both x-intercepts and y-intercepts. I want you to take a second, look at this equation, ax plus by equals c. Why would I say that it's actually pretty nice for us to find x and y-intercepts from the standard form of the equation of a line? I am curious to see your thoughts, but I'm really hoping some of us are able to say, hey, like, yeah, if I am trying to find my x-intercept, I'm plugging in 0 for y. This whole term plus by, because y is 0, is going to cancel out. And I like to kind of think about this as like the cover-up method, because essentially when you're trying to find one of your intercepts, you're just able to cover up a part of your equation. So for my x-intercept, I'm just looking at ax equals c. And when I'm trying to find my x-intercept, the value for my x is just going to be, if I divide both sides by a, is going to be c over a. That's something you can memorize. That's something you should be able to know how to do if you're just plugging in 0 for y anyways. But that's why this form is really nice for us. We're able to cover up or cancel out part of our equation to find one of our intercepts. Same thing goes for my y-intercept. I plug in 0 for x. This first part of my equation is gone. I'm just focused on by equals c. And so my y-intercept is going to be always, always, always 0, comma, c divided by b. Let's talk about slope before we move on to some practice. If I am trying to find the slope of a line when it's in standard form, that is going to be negative a over b. I could rewrite this equation in slope-intercept form and use my m and do that, which, it's fine. You can. There's nothing wrong with that. But if you're trying to do that for every single answer choice to test it, it takes time and it takes energy that, frankly, I don't think any of us want to spend doing. I wouldn't. It's nice to know that, hey, as long as I can just pull out my a and my b value, divide them, and change the sign, right, because it's negative a over b, I have my slope. I don't have to do any other work than that. Now let's go ahead and talk about some practice. So the SAT does like to ask you about slope, and really for the most part these questions are pretty straightforward. They will give you a graph and ask you about slope that way. They're really just wanting to make sure that you know that slope is y2 minus y1 all over x2 minus x1. And so when we were looking at this first example, whoa, that zoomed in a lot. When we were looking at this first example, it's what is the slope of line t? You kind of have a few options, and one way that the SAT likes to make it a little bit more complicated for you is by making you like deal with kind of nasty numbers, right? Like -6 comma -27 over 5. Not here for that today, but you know what? It's the SAT. We got a deal. And so you can go ahead and like pick any two. I could pick these 2 points. I could pick these 2 points. I could pick like this point and this point. It doesn't matter, right? As long as I'm picking 2 points and plugging them into my equation, that y2 minus y1 over x2 minus x1, I can find my slope. The nice thing about this question is that it is Calc OK. So as long as I plug that into my calculator, I can let the calculator do the work for me. And that is probably what I would do. Another option for us is, for those of us that are a little more calc savvy, you could pick 2 of your points, put them in your table, and run a linear regression, right? We did that in Unit 1. It's been a while, and we'll get more practice, but that is also an option for you. Run a linear regression. It will give you the slope between these 2 points, which is, the same thing that you'd be solving for anyways. And so when you do that, again, I can just pick any 2 random points. I pick these 2 on the right, got my x1, y1, x2, y2, plug them into my equation, and I could literally plug this into my calculator, and it will give me 0.4 for my slope, which is what I would bubble in and move on. Let's go ahead and talk about another example. We see an example here, which is, again, Calc OK. And so something you could do is pick 2 of your points, plug them into your calculator, and deal. But this one's something that I would hope that we can use our graph and just look at and come up with our slope. Something I noticed is really like to pay attention to my y-intercepts. All of these equations are in slope-intercept form. So my y-intercept should be added to the end, and I see that in options B and C. So I don't like A and D, because my plus 5, my y-intercept. Now I'm down to my slope. Now if I'm looking at this graph, something that stands out to me is like, hey, slope is rise over run. I'm going up 1, 2, 3. I'm going over 1, 2, 3, 4. And so my slope must be 3 over 4. And so I would say option B, but that is wrong. Something else the SAT will do to complicate your life, and this is something we need to pay attention to, so I'd write a note to yourself. Pay attention to your axes. What do we notice? On our y-axis, each box we go up does represent 1 unit that we are increasing. But if we're looking on our x-intercept, right, each box does not represent 1 unit. We actually have to go over 4 whole boxes to represent 1 unit on our x-axis, or in this case, h. And so our slope is not 3/4. It's actually, yes, we are going up 3 units in y, but we're only going over 1 unit on our x-axis. And so our slope is actually 3, which means our answer is C. Pay attention to your axes. The SAT will try and trip you up, but you're better than that. Don't let them trip you up. Now let's talk about the part that we're really here for, which is when our equation is in standard form. So if we're looking at this question here on the left, this first one, that is no calc. Which of the following equations represents a line that is parallel to the line with the equation that is given? Remember, if we're talking about parallel lines, so parallel lines, those have same slopes. Same thing if we were talking about perpendicular lines, those are opposite reciprocal slopes. In this case, we're talking about parallel lines. It gives us this equation, y equals negative 3x plus 4. You could tell me that the equation of this line is negative 3. And so that means that I'm trying to find the equation of a line that is parallel, which would also have a slope of negative 3. Now, I could try and convert every single one of these answer choices into slope-intercept form and find my slope and move on that way. But I'm telling you, it's going to take way too much time. And it's going to take way too much effort. we know how to find the slope of a line when it is given to us in standard form. Tell me right now, how do we do it? Yes, we are taking our a value, dividing it by b, and changing the sign. That is exactly what I'm going to do for each of these answer choices. So a divided by b, 6 divided by 2, change the sign. That gives me a slope of -3, which is, well, that works out nicely. That's exactly what I'm looking for. So it looks like a is going to be our choice. I'm going to go ahead and do some of the others just to make sure. A divided by b, that's 3 divided by -1. Change the sign, and we get +3, so that's a no-go. Let's see, 2 divided by -3, change the sign. That gives us 2/3. That is not what we were looking for. And then the last one, 1 divided by 3, change the sign. We get -1/3. Looks like A is our option. That took no time at all, people. -A over B is our slope when we are in standard form. Let's talk about question number 2. The line with this equation is graphed. What is the x-coordinate of the x-intercept of the line? When we are looking for an x-intercept, that means we have some number for x, and our y value is 0, which means we're going to use the cover-up method, because when we plug in 0 for y, this part of our equation goes away, and what that means is we are just solving this equation, 4/5 x equals 1. In order to do that, I'm going to multiply by the reciprocal. So multiply both sides by 5/4. By 5/4. The reason we do that is because cancel, cancel. We're left with x equals, well, 1 times 5/4 is 5/4. And we would just go ahead and box or bubble this in on the SAT. And then life is good. We move on. Super simple. Let's do one more example together. What is the y-intercept of the line? See if you can do this on your own before I walk through it myself. Yeah, if we're finding the y-intercept, that means we are plugging in 0 for x, which means we are covering up or canceling out this term in our equation and just trying to solve 3y minus 3 equals 0. When we do that, we get 3y equals +3. Divide both sides by 3, we get y equals +1. That is going to be our y-intercept. Oh my gosh, people, look at how much we can do in such a short amount of time. Okay, I lied. Let's do one more. This says you try. I'm going to give you a chance to do it on your own right now, and then I'll walk through it. You could be tempted to rewrite each of these answer choices in slope-intercept form and find the slope, all the good things, but we don't have to do that. What I notice when I'm looking at this graph is I'm given my x and y-intercept, which I know, based on my answer choices, which are in standard form, I can actually work with that pretty easily. I can use the cover-up method and make sure that both my x and y-intercept are at -4. Because x-intercept's -4, 0, y-intercept is 0, -4. And so let's go ahead and start from the top. If I'm looking for my x-intercept, plugging in 0 for y, I get x equals -4, which is what I want. Let's go ahead and try the other way. Cover up my x. Well, -y equals -4. Divide both sides by -1. I get y equals +4. I don't like a, because I don't get my y-intercept at -4. Same thing here. Let's find our x-intercept. X is +4. That's not what we want. We want negative. Option C, x-intercept is -4. We love it. Let's go ahead and try our y. Cover up method for our x. We get y equals -4. Yay, that is what we want. Both our intercepts are -4. And then we'll prove it by doing option D. Cover up any one. We're going to get y. Our y-intercept is at +4, which is a no-go for us. Option C. All right. I want us to get into the level 3 and level 4 practice. A little bit more challenging, but definitely something that we are very capable of to get us ready for the SAT. Let's go.